Hello guys, welcome back. So as we have discussed in the previous lecture about the bubble sort, so in this lecture let's see how we can implement the bubble sort, right? So without wasting any further time, let's get into it. Okay, so for the bubble sort we first need an array, right? So let me quickly remove the autosave, right? So let's create an array with some unsorted data. Let's say 43 to 89, 56, 73, and then let's add some more 0, and then 9 is not there, right? Okay, now see, I'll show you one of the simplest way of like writing the bubble sort. Okay, so in this what we will do, let me create a function quickly first. Bubble sort. Okay, so in this what we will do, we'll simply pass the array and then we will run two for loops, right? For loop for parent array, or we can say array. Okay, what will happen here, like we are going to iterate through this array, right? And we are going to check like if the two elements are matching, like not in correct order, then we are going to swap it. Okay, and how we can keep this run over and over again, right? So for that what we can do, either we can use while loop or we can use like nested for loops, right? So let's go with the nested for loops. Okay, so let's use for let I equals to 0, I is more than length, and then I is I plus plus, right? So this is our first for loop. Basic things you guys might know already. Okay, so now I'll create another loop. So what will happen, it will keep on iterating this loop over and over again, right? So we don't want it to run only once, we don't want it to iterate this loop to iterate through this array only once, right? Because see, in first iteration, like it will just swap few elements, right? It will not sort the array completely, right? So that is why we need a second for loop which will basically keep on running to check if we are getting any unsorted data. Okay, so let's name it as j equals to 0, and then j is more than again this condition basically. So let's paste it here, and then j plus plus. Okay, now here what we can do, we can simply use the swap function, either this one or this one, right? So let's go with this one, or you can use anyone, right? So we already have wrapped them into the function, so that doesn't matter at all. Okay, so let's use the swap old method where I'll pass what I have to pass in it, by the way, array, right? So I'll pass the array here, and then what I have to pass, see, here I have to check the what to say, the adjacent numbers, right? So if these two numbers are not in correct order, then I have to swap them, right? And then I have to check if these two numbers are not in correct order, then I have to swap them, right? So what I can do, I can simply write an if condition. Okay, so if array at position j, because you have to keep in mind, you have to write that condition inside this for loop, right? Otherwise if you write it here, then it will just run once, right? So make sure you have to write it inside the another for loop, right? So if array at position j is greater than array at position j plus 1, okay, so that means this one and this one in the nested for loop, and then in the next iteration it will be this one and then this one. So in the next iteration this one and this one, right? So yeah, if it is greater than the array at position j plus 1, then we are going to call this swap method. Okay, now here what we have to pass, we have to pass the indexes which we have to swap. Okay, and then j plus 1, right? So that's it, right? So now what we can do, we can quickly refactor the code. See, this is the code which we need like to implement what we can say basic bubble sort, right? And it's not completed yet, and let me show you how. There's still some problems with it, but let's see. Okay, so bubble sort, I'll call here, let me stretch it a little bit, and I think it's zoomed enough, right? So bubble sort I'll call with the array, right? Array we have here, let's see what happens. Okay, we are getting nothing because we have done a little mistake. Not we, I have done a little mistake. I haven't written anything at the end. Return array, right? So array we have to run after sorting, obviously we have to return something, right? So I forgot to return it. Let's see right now what happened. As you can see, 42 to some places, in some elements the order got switched, right? See, 0 came here, and then 2, what to say, 2 is still here, and then 9, and then 43, 56, 73, 89. So it is almost sorted, right? So you can see like this thing is completely sorted right now. So you will think it's a final solution, right? But actually the thing is it is not. Okay, and let me show you the problem with it. Even though it looks like the array is sorted, let me show you the problem with it. Okay, so let's where I can write that, actually let's write here. Okay, I plus j, here we are comparing it, right? So let's write a console log here to see like what we are getting. We are going to get a lot of array at position. Let's compare these two, okay, directly. Array at position j and array at position j plus 1. Okay, so here we will get to know what is wrong with the array, right? And then let's actually log the array as well. Okay, see, in the bubble sort, what I have explained or what we know so far is like whenever we are looping through the array, okay, so at the end we will get a sorted element, right? So what should happen in the next iteration? We should not include that sorted element. It should be semantic, right? We should only iterate through the rest of the elements, we should only iterate through these elements, and then in the next iteration we should iterate through these elements, and then like these elements, and then this one, and then the single element, right? So basically this way, I think I have already added the pattern here, right? So this way we should iterate, but here what is happening, it is keep on iterating on every element over and over again, right? So let me quickly show you that. So now if I run it again, okay, so it's a big loop right now, right? See, here it is comparing 43 and 2, right? This is I think this is this 43 and 2, that is fine. We are looping through the array, and then in the next iteration it is it basically switched the places 43 and 2, and then in next iteration we are comparing 43 plus 9, 43 and 9. So here 43 came, and 43 and 9 we are comparing, so nothing will happen, I think. Okay, and then 89 and 56, these two we are comparing, right? And then 56 and 73, okay, sorry, this two will get switched, so 89 and 73 we are comparing. Okay, and then what we'll do, the places will be switched between 89 and 73. So next iteration we will compare what to say, 89 and 0, right? See, and then 0 and 89 will switch their places, and then we will compare 89 and 9, right? And then as you can see, after comparing this iteration, like it is going out of the array, right? We are getting undefined here. It is trying to compare with the j plus 1, which does not even exist, right? So you can say like it have reached the last element, but still it is trying to compare the last element and last element plus 1, which is not existing in the array, right? So that is why we are getting undefined, and it's not just one problem. Okay, now if you look at the other iteration, right, here also it is comparing all the elements over and over again. See, if the 89 is already sorted, then why we need to access it, why we need to loop it again, right? So see, all the elements it is accessing over and over again. So this is basically the problem with the basic for loop, with the basic bubble sort which we have implemented, right? So in small array, in small data set it's totally fine, but in large data set it can be problematic, right? It can be slow. So what we can do, we can simply optimize it a little bit. Okay, there's no drastic change, but we are going to simply optimize it. If you want, you guys can take a screenshot of this, so before I change it to the actual bubble sorting code. Okay, so I hope you guys might have taken the screenshot. So let's continue with it. Okay, so here what I will do, I will basically run the first for loop from the end of the array, from here. Okay, and then this for loop I'll try to run by with I minus 1. So in the first for loop it will be like this, second for loop it will be like this, third for loop, it will be like this. I'm talking about the nested one. Okay, so the third internal for loop will run from here to here, and then fourth will run from here to here, and then from here to here, and so on, right? So let's implement that quickly. So here, instead of using array dot length here, let's use it here. Okay, array dot length, and array I is greater than 0, I will use here, and then I minus minus. So basically simple reverse for loop, right? You guys might know already, it's a basic thing. Okay, so this is a one change I have done. Like I'm iterating from the end of the array in the first for loop. Now in the second for loop, what I will do, I'll simply use I minus 1, I minus 1, and we are done, right? See, so what will happen now? It will simply, instead of accessing all the elements over and over again, what will happen? It will uh, it will ignore the last element every time on every iteration. Okay, so now let's see what happens with this one. So this is the basically logic here, and then let's run it. Right. So now as you can see, we are running 43 2 and then 43 89, which is this array. See, 43 got switched with 2. So this time we are comparing these two elements, or let me stretch it a little bit, these two elements, and then in next iteration, we are comparing these two elements. In next iteration we are comparing these two elements. Okay, and next iteration we are comparing these two, and then we are comparing these two. Okay, so we have reached the end of the array in one loop, right? Let me just add some separator here, because it will be hard to see where the parent loop is, or we can say the child loop is ending, right? So let me add some separator here. Okay, child loop ends. Okay, so this way we will get to know how many times we can clearly see how many times the parent loop is running and how many times the child loop is running. Okay, I have not saved it, so that was not good actually. Okay, so now at least we can see clearly what is going on here, right? See, in the first parent for loop, we have iterated through the elements this many times. So in the first iteration we are comparing these two, second iteration we are comparing these two, we are swapping the elements, and then in the third iteration we are comparing these two, and then fourth iteration we are comparing these two, and then fifth iteration these two, and then sixth iteration these two. So here we had 6 iterations, right? Now in the second for loop, in the second parent for loop, we will have 5 iterations, 1 2 3 4 5, and we have 5 iterations, right? So this time we are ignoring the last element because it is already sorted, right? So now here we will compare 2 and 43, and then 43 and 56. Since they are in correct order, we are not swapping them. 56 and 73, they are also in correct order, we are not swapping them. 73 and 0, they are incorrect, so we will swap their position. And 73 and 9, right? So they are also in incorrect position, we are swapping them. Okay, now in second the another for loop, next for loop, we can say we'll have 4 iterations. So this way, the child loop will keep on decreasing. Okay, because we have sorted last 2 elements, so it should only loop till this array, right? Till this element, till this 9, right? And in the next for loop, it will iterate till this element, it will ignore the last 3 elements, we can say, right? So let's see what happens here. So 2 and 43 we are comparing, right? And then in next iteration we are comparing 43 and 56, and then 56 and 0 we are swapping their places, and then 56 and 9 we are comparing, right? And since it is incorrect, so we are swapping their places. Okay, that swapping you will see in the next iteration. Okay, now 2 and 43, as usual, nothing will happen. 43 and 0, it will swap, and then 43 and 9, it will also swap, right? Now in the next iteration, as you can see, it is keep on shrinking, right? So that is what we wanted actually when we are working with the bubble sort, right? We don't want to access the element which is already sorted, right? That does not make any sense, right? So now if you see here, we are comparing 2 and 0, we'll swap it, and then 2 and 9, we will swap it, right? So 43, 56, 73, 89, it is already sorted, so we are not touching it. Now in this one, see, in this one we already have everything, what to say. So we already have everything sorted here. So we are comparing the first two elements, and then if it is like not in correct order, we are swapping it. If it is in correct order, then we are simply ignoring it, right? So this is the thing. At the end, we got our array sorted, right? So let's try to quickly call it with some negative numbers. Let's see what will happen. Okay, because I just wanted to make sure whether it is working properly or not. -1, and then let's add -13, and then let's add some positive numbers. 11 is not there, right? Okay, so now we have -1, -13 and 11. Let's see how it goes. Okay, so let me stretch it here. Okay, so at the end we got the array -13, -1, 0, 2, 9, 11, 43, 56, 73, 89. That means our sorting logic is working fine, right? So this is what we call a bubble sort. This is how we implement the bubble sort, right? But this is also, I can say, is not a final version of the bubble sort. We can still do some optimizations in it, right? Or if you find it fine, then you can go ahead with it. But in the next lecture, I'm going to show you that's going to be a quick lecture, okay, where I will show you like how we can optimize this solution, okay, and we'll talk about the big O of the bubble sort. Okay, so yeah, I'll attach this code, this particular code in the description. Make sure to go check it out, and then this is it for this lecture. See you in the next one.